Alright, so let's see. Yeah, the 1/4 is still there. When x is 1, u is 4. When x is 5, u is 148.
So I did 5.
That you should put 4 then, right?
4, yeah, 4 things. That's what you mean.
Yeah.
Okay. And then in here I can put this and this is the u, and this now is u to the 1/2. I love it. Cool.
So either we choose to just substitute 148 for u, or we take u back to the x
And we leave it with 1 and 5. Exactly.
So when you take u back,
Both of them are mathematically the same. Math doesn't care.
So when you take the u back, then you just plug that would be just when you plug the 6x squared minus 2 back in for u, and then you just.
And see how, in that case, you're going to figure out what 6 times 5 squared minus 2
Right.
is anyway? Because you're going to plug a 5 into it?
Why
So to me, it just made more sense to do that.
How do you do it with the u's then?
So let's see, 1/4, what's the interval u to 1/2?
U to the 3 halves.
2/3.
Good.
The 2
So I get 1/6 u to the 3 halves, so I get 148 to the 3 halves minus 4 to the 3 halves.
Oh, and then you would just plug in the x at the very end. That's confusing.
You don't have to.
Oh no, because it would just
No, I don't need to go to x at all. It's a definite integral. So all it needs is for values to be plugged in and come out. If I change my variable from x to u, I have the option to change my limits from what x does to what u does.
Fascinating.
I like that word. And you know, real quick, I mean, this let me show you what it looks like if I did it the way that I normally do it. And you'll see, I mean, this is really kind of silly little distinction here. So I would do this. And then I'd say, okay, that's 1/4 times 2/3 u to the 3 halves. And then I'd say, okay, that's 1/6 6x squared minus 2. And I can take my parentheses off because now they deal directly with the variable I have in there. When I throw a 5 in there, I'm going to get 148 to the 3 halves, right? Of course I am, because that's what we got over there. When I throw a 1 in there, I'm going to get 4. I mean, do you guys see? So here I plugged my x values into u first, and then I integrated. Here I integrated, and then I plugged my x values into u. Who cares? Math doesn't care which one you do first. So see how this whole discussion, on one level, it's silly, but you got to see it first before you realize that. Oh yeah, it's just, I don't care which one I do first. You just got to do both of them. For me, I don't know why necessarily. I just like doing it that way, yeah.
If we don't put the parentheses around the numbers, like 1 and 5, are we going to mark out
Oh boy. I really hate to set you up for 280 based on who your instructor is. Because I don't know how they're going to react if you do it this way. Do you know what I'm saying? So I like to show you the complete way. And at this level especially, you start to realize that you can make all of this your own. Right? But you got to realize when you go to somebody else, sort of like when you go to a presentation, I wouldn't do this if I was presenting a paper in front of the Mathematical Association of America. I wouldn't do this because it's just not a practice that everybody understands and does. I would just go ahead and do it that way because it's more widely understood and accepted. Do you see what I'm saying? So if you go to the next instructor in 280 and they are somebody who doesn't understand this, they might have a big problem with it. I'm not trying to set you up. I just want you to see the kind of stuff that you have some flexibility on personally. But somebody else might want to see. You might want to say, I do stuff this way. Do you have a big problem with that? Because I understand mathematically it's the same. And they might be cool with you explaining to them that you understand it's the same. Right? That's what I tried to do. And most of my instructors are cool about it. Okay, good. Yeah?
We do 3 or 2C in practice.
So let's do this one, and then I'll go ahead and give you the answer key. This one here? So again, this is another one that's disagreement. You can tell exactly what's inside. And certainly the stuff that's outside is its derivative. minus a constant, right?
So the 2 minus x cubed is the u.
Good. U is 2 minus x cubed because that's the part that's stuck. But more importantly, that's the part whose derivative is outside.
Which is, we just hit that 3 on the outside.
Exactly. So we'll have
3x squared negative x.
So then I need a negative 3, so outside I put a... Cool. Oh my gosh. Sorry. I lost a few brain cells now. So this will be negative 1/3. Negative 3x squared dx is du. And e to the u. Gotta love that stuff. So again, you have the same... I'm just going to do it my way. But you could change the... You have u equals 2, so you could put a 2 in there and a 0 in there. You guys follow? Doesn't matter, right? It's like... E to the u integral is... Yeah, e to the u.
Negative 1/3.
Yeah. And then I want to go from 0 to 2. I don't know, you guys, are you with me? I always worry too much when I think I go too far before you're fully with me. Because now you just got to plug a 2 in there and plug a 0 in there, right?
Oh, that's a 0, not cosine. I was thinking the bigger near.
This thing here?
No, on the bottom.
Looks like close.
Oh, it does look like cosine.
It's just, I couldn't quite figure out how we were going to solve for that.
Now it looks like some way to look at it. So now you get negative 1/3 e to the 2 minus 8 negative 6. And then when you do 0, it's minus negative 1/3, so plus 1/3 e to the 2. Because it's f of b minus negative makes it plus f of a. Yeah.
Right.
Is this sufficient, or we have to do with this one?
I would prefer that, to be honest. But and I understand this is kind of unsatisfactory. So I don't mind if you show me this and then you show me what the decimal is. I totally get that, because in a way this is like, I wouldn't say, how much time do we have? 1/3 e squared minus 1/3 e to the next 2. Right? Yeah.
So I got a question on how come we never add C on these type of problems?
Okay, if I put a plus c there,
Yeah.
so let me show you this step a lot more explained. So it would be negative 1/3 e to the 2 minus 2 cubed plus c, right? Plug a 2 in.
Right.
Minus negative 1/3 e to the 2 minus 0 cubed plus c. Look what happens to the plus c's.
Oh, they cancel out.
And that would happen every single time. So that's why for definite intervals, you just skip the step of putting a plus c in there, because it's going to die anyway. And that's sort of, I really want you, I know this was oriented the wrong way around, but it's actually related to this. If I move this around, the area doesn't change. And remember, this is in terms of y, so plus c would actually move it up or down. But the area doesn't change, because the plus c is just going to cancel.
So why does the functions itself change?
Huh?
What's the functions itself change?
Yes,
With the area change?
I like it. Exactly. Good.
So,
Yeah.
this is a quick one. Just looking at number 6, this is the one where we're saying that you leave the constant alone, you use the function or a variable inside of the function of the part to be integrated, and you differentiate that, right?
No, you're talking about the fundamental theorem of calculus one? Yeah. Good. This is actually, I didn't put this on the answer key because I ran out of room. I'm glad you brought this up because I want to do this together. So in general, note, g of x is defined to be, can be defined to be this. All right, it's just not every g of x is not this. So if I had g of, I don't know, secant x, what would that look like?
T will from A to secant x.
See, that is where inputs go, right? That's defined to be where my input goes. The rest of this is basically just the general format of every function. So it's like the square root symbol. And what's the input? It's going to be whatever the hell's there. So I know if I take the derivative of this, what's going to happen?
It's going to be from A to secant x.
What's the derivative of g of secant x? Don't even look at that side. Just the integral of this. I mean, derivative of this. It'd be g prime secant x. Am I done?
Times the cos. Oh,
Tangent secant.
thank you.
Times, yeah.
You guys got it with me? All right. Let's see if you really are with me. Because now, if I just take this out, this is still true. If I want to take this guy's derivative, the derivative of the integral of this is defined to be f evaluated at this. That's fundamental theorem calculus part 1. That actually is like defining what the derivative of tangent is. Right? There's a rule for it. Chain rule is not a part of that derivative rule. Chain rule is just always true, right? So just because I define a new derivative, it doesn't mean the chain rule doesn't still get its turn. Of course it does. You have an inside function. So this has to be times secant x tangent, the derivative of secant. Yes, sir?
Will you have any weird sign changes or anything if you have the function or variable switching position between A or B?
Well, that's exactly what number 6 does. So now I've worked my way up to number 6. So this is all the note. That was my big-ass note. And here's number 6. Number 6 says integral secant x to 5 or something. Secant root t dt. And I want to take the derivative of that. So the first thing I want to do, because this is not in the right form, it's sort of like having 1 over cube root of u. I'd much rather write that as u to the negative 1/3, because then I've got to apply the rules in the right form. So why is this not in the right form?
So you flip it, right?
These are in the wrong place.
Negative something.
So this will equal negative.
5.
Oh, is that 5? Okay.
You're on me about that today.
Number 6.
Oh, is that English, Jeff? Oh, this is not English. So I'm still not primary. The derivative rule for integrals is that you take this function and you shove this into it. Right, so you get negative secant square root of secant x. That's just like taking the derivative of 3x to the 1/3 and having 1/3 3x to the negative 2/3, but you haven't done the chain rule yet. So this is the derivative rule for integrals times chain rule.
Yeah, so just that.
Secant x, tangent x. I like it. So that is yummy. And one thing you guys have to really be careful about, what exactly is this?
That's just the your original integral.
The derivative.
What is it? What's inside of what? What's going on there? This is a square root of secant x.
The value, right?
The square root of secant x inside of a secant. So that's very different from that, right?
Yeah.
That would be the product of secant x and square root. So these are remarkably different. I don't think you guys appreciate, some of you don't appreciate the difference between tangent x sine x versus tangent sine x. These are not the same thing. This is the tangent of the sine of x. This is the product of tangent and sine. So desperately different. So I just want you to be careful. Yeah.
So why was the square root piece left out? So the 1/2.
Oh,
What the chain rule does
how do I say this?
is because.
I got sort of an analogy for you.
Okay.
And I'm integrating this, which would be disgusting. So when I differentiate the integral of this, I get this back.
Yeah.
So of course I'm not going to do anything with that. It's already kind of done. And the analogy I have is not perfect because it just can't be. But if I have this, the 3 changes, but the x minus 2 doesn't. Right? Because the square and the square root die. So this and this cancel. So that's basically still there. It just gets evaluated at that endpoint. I like it. So you don't have to worry about 1/2 t to the negative 1/2 because you're not taking the derivative of this. I'm not squaring this because it doesn't survive to get in there.
Okay.
But you see,
It
you
dies
just
right
take
off
the
the bat.
derivative of that little piece that you're putting in.
because that's the chain rule. That's the inside function, because normally it's an x there. So if I put a secant x, that's an inside function. That's a chain rule. And that's on top of just the normal rule.
So instead of secant x as the b, if you put like x, would it just be negative secant root x and that's it?
Oh, this was just an x?
Yeah.
Then it would just be negative secant root x.
Okay.
Because the derivative of x is 1.
Yeah.
Good.
That would be
Still chain rule, but it just doesn't show up because it's just a 1.
And the negative is applied on the inside because you're taking the derivative of the whole negative integral, correct? So that's why it's negative secant on the inside instead of the negative on the outside.
Just flip that first time. Is
Is it supposed to be on the outside?
It doesn't matter. They're both the same thing.
That's what
Yeah.
Would you be able to do H?
Yeah, let me do this. Let me give you guys the answer to you. I told you. I'll give you guys. I'm thinking of myself before I done that.
We're gonna put the.
You don't have to. Because if you always for the 5, it's 0 minus the bottom, which would be negative anyway. That's just a shortcut.
I have to remember when I do it, my habit can just like be lazy and not switch them up to negative. And it won't work.
It's the same thing. Get it by hand.
Oh, sweet.
Remember better if you see it.
Looks huge. It's so
Probably so good luck putting it in.
3x.
I know.
H. 3.
Good luck with the answer.
Good luck understanding what he wrote.
Yeah.
was trying not to take that first.
No, you passed out quiz 4,
Yeah.
but
I know, I already had
Quiz
quiz
five.
4.
Yeah.
I just like the number 4.
So you get extra points on practice.
We had a running gag in university because we all didn't know the answer to something, so we were like, put 4 down. We put 4, and it turned out to be the right answer. So throughout the whole time, we said, I'm not sure, 4. Oh yeah, it's got to be 4. But so yeah, I just kind of inherently
The whole class put 4?
like 4. Huh?
The whole class put 4, or just like?
Well, just people around us who were doing like group work. We're like, I don't know, put 4 down. And then 4 is the answer. So for the rest of the time, we're like, I don't know, 4. It's got to be 4. That's the problem with inside jokes, is normally they don't sound very funny. Outside. I think I left off 5G also, so we could do that one together. 5F, notice on 5F I circled it and said this is a shell. But 5G should not be. Okay. So I forget what the question was just now. Hopefully that'll help.
You said 3H is what you said.
Did I do 3H? Yes. Does that make sense, no? Let me see.
Yeah, you did.
Inverse function.
So I kind of didn't show every single step there, so let me
This is
see.
the fifth root, right? Not that outside part to the fifth.
It's the 5th root, yeah.
Okay.
Yeah. Because it's sitting on that radical.
That's the last.
Please, if something like that happens on the test and you're not sure if it's a power or a root, something like that, just ask me. It's not a big deal. So 3H.
Just to real quickly check. I know you said just to miss it. Why did you say you didn't do 5G on the practice test?
I just ran out of room.
Okay.
I think, right? Yeah, I ran out of room. I didn't want to do a whole other sheet just with 2 problems. All right, so again, you start to see how this looks totally different to some of this. It's the same damn thing again, right? What's the inside function? And this is where you got to be a little careful.
You did the 3x and
Yeah.
the 6x.
3x minus 6x to the power 4.
Now, if I make it to the power 4, its derivative will not be out here.
You're right.
The 4/5.
This is related to this.
The 4/5 happens afterwards.
So the 4/5 is what u will be raised to. So it's not a 4th power. I want to let u equal just this piece. That's kind of related to earlier. It sounded like we weren't sure that we were allowed to do that. You're totally allowed to do that. So this is, if I let u equal to this, And the whole motivation for that is because this guy's derivative looks like it might be here. What do I get when I take its derivative?
3e to 3x minus 6.
Which is 3 e to 3x minus 2. So that is there. I'm just missing a factor of 3.
So 1/3 on the outside.
Good. Now, I can't remember. Remind me. Did I show you what some people do? I know it's a very
Such a vague answer.
well, it's a very vague question too. Really. Did I show you something? Maybe. If I divide both sides by 3, then I get exactly what I have in here, right?
Yes.
Yeah.
You told us about
I hate that. I did tell you about it?
Yeah, you said you
Because people do too much here. They make a mistake. They realize they need another x, so they divide by x or something weird.
Oh, yeah.
So easy to make a very simple mistake there when it's so much better to not do that. Just make sure this shows up in there. Then you're not going to make that mistake. And it's not that hard. Put a 3, you put a 1/3, you're there. So now I get 1/3. This is
2 other sets canceled.
du. And then this is Careful. Roots on the bottom of plants. So roots are on the bottom. Powers are powerful on the top.
Oh, that's really clever.
I
I
know.
didn't know that one.
That's what I teach
That's the
my,
first time I've ever heard that
for
one.
my 90. I think it's 90 or one of them. Roots on the bottom, and I always tell people, no botanists in here tell me about potatoes and whatever tubers and shit. Most of the plants, the roots are on the bottom.
Yeah.
So 1/3. What's the interval of this? Careful.
No, it'd be 9. Oh, no, 4/5.
9 over 5 ninths.
9/5 of 5/9. So,
I was thinking
guys,
E.
when you're doing the power rule, you have to first find the power because then it's that new power that you divide by.
Yes.
Right? So you have to reciprocate the new power, not the old power. And then, of course, that's going to be 5/27.
That stuff.
3.
2 to the 9/5 plus the 8.
Cool. See, this would be relatively quick to check, right? So on a test, you do it all, and then if you have some time at the end, you go back and check your intervals. Just take the derivative, make sure you get back to what you had in the original.
Take the derivative of that.
Cool. Derivative of this.
Yeah.
Now that should be easy. Right? I should have no problem saying that and have everybody agree with me. The derivative of this is easy. Okay. So let's do 5G because that's one I left off of the answer key. So if you have not tried that yet, go ahead and try to sketch the region that I'm talking about. Oh, 5B. I forgot about this. 5B is from the last section in chapter 6. So I'm not going to put that on there, but you can see how the average value of a function from A to B is going to be 1 over B minus A times. It's sort of like the average. How do you average something? You add them all up and you divide by how many there are.
Yes.
That's basically what that interval is. That's the last section in 6. Is that quick and silly, actually. But, I'm not going to put that on there because we haven't done it officially yet.
3, the brackets of 3, 4 is just from 3 to 4. Correct.
Yes, 3 to 4, inclusive. Yeah, 3 to 4.
Just because I don't think so.
Mm-hmm.
Is it supposed to be plus 2? Is that supposed to be plus 2?
Yeah, it's very quick, lazy plus 2. So by the time you get to 5G, you've already gone through the work on an earlier part where I ask you to find out where they meet. All right, so when you solve f equals g, you get x equal plus or minus 2. So they meet at -2 and 2. So a very quick way to graph them in is you just want to know what they are at -2 and 2. So at -2, they're both going to be 4 plus 6 plus 6, so 16.
Or no, right.
And at 2, they're both going to be 4 minus 6 is -2 plus 6 is 4. I did that right? Who knows anymore, Jeff? I don't know. And then you just have to know are you guys, the most important points, of course, are where they meet. And then to get a quick rough sketch, I just need one more point, really, because I know they're both opening up parabola. So if I look, the y-intercepts are going to be 2 and 6. So then I have this guy, and I have this guy, very roughly. I don't know where their vertices are. I don't care. I just need a real rough.
That's a banana. That's a banana.
I love it. You get a lot of bananas when you do this, believe it or not. All right, a lot of banana regions. This just sounds cool. I like that. Where are you from? The banana region. All right, and I'm going around y equals -2. My scale is really neat, but I won't. So I want to. That's a really big banana. Do you have a banana for scale? Okay. So if I'm going around y equals -2.
You have a cat, right?
Say again?
You have a cat, right?
I thought you said you have a cat. Good. I have a gap, so it's going to be a problem where I'm going to need to figure out eventually what two things are outer and are inner. I like it. But first thing is, remember so we can sketch the graph. Integral d what? Because it's parallel to the x-axis. I like it. And now I just got to figure out what r outer squared, or r outer and r inner are, and then I can just plug them in. So r inner, you start from where you're rotating around, and you go out, and you stop when you hit the first two. Now, which dude is that? That's the important part. That's going to be the y-intercept that's lower.
G.
Good, so that's g. So r inner is going to be g of x. So r outer, curly enough, must be the only other thing I have.
But
Or
it's
G.
to the y-intercept of it.
Oh, I'm sorry. Plus what?
Plus the y-intercept of it, right?
Plus, how far do I have to go just to get to the x-axis? 2. So they're both going to be plus 2.
Right.
Cool.
Oh, you mean when you plug them into the bottom, they're going to build?
So remember, the radius is how far away from the rotation axis you are. Right. So if I'm rotating around this axis, how far away I am is the radius. Right.
And because it's
So I'm rotating
-2.
around this. So how far away am I? Not just this far away. I'm plus 2.
Oh, okay.
Does that make sense?
Yes.
So whenever you're off axis, you got to be careful about adding or subtracting that much, because I could have done around y equals 1, and then it would have been a little closer. I would have had to say f of x minus 1 and g of x minus 1. Does that make sense? Okay. So now you just plug and chug and you go to town. What are the limits?
-2.
-2 to 2. We figured that out earlier. Okay, you're 9. Whoa, I like it. Our outer is going to be f of x plus 2, so x squared minus 3x plus 8 squared minus 2x squared. Get out of there. Minus 3x plus 2
Plus 4.
plus 4, thank you. Plus 2 plus 2 plus 4.
Plus 2 plus 2. Plug the numbers.
And now you just FOIL, get your like terms together. Right? I'm not going to do this to you too often. I'm not going to give you like a bunch of stuff to square. Right? Kind of with me? Because that's just busy work. Yes, sir.
Why are we adding 2 to the 2 functions? Is that because of the distance between the rotating points?
Yeah, if I rotated my banana around the x-axis. It sounds suggestive. It sounds painful, actually. If I just rotate around the x-axis, I'm exactly, for example, I'm exactly g of x away. So my radius would be exactly g of x. But if I'm rotating around y equals -2, I am 2 plus g of x away.
So it's like a shift.
Yes.
In a way, sure. But the way to just think of it most directly is how far away are you from the... So once I'm off axis, it's a shift. You got to add or subtract because of that, how much is moved. I like it. Okay, good.
Oh, I see.
Okay, good. Some of the worst grammar ever, but it actually made sense. Okay, good. And I'm not going to do that. You guys can square and all that kind of stuff. Side. So, yeah. So again, I don't know if you heard me, but giving you a problem like that on the test, I'm not going to do it. Where you have to square something out like this, and that's just silly. But you will have to square like 2 terms. So that's not a big deal. Yeah.
The answer for 3C, is that pi t plus c?
Pi t plus c, yeah.
Oh, that's pi t plus c just because that's a constant.
Yep, pi is just a constant. So it's just like 4. The integral of 4 dt would be 4t.
Like 3b just says can't
Just to say,
do.
like, you don't want to, it's perfectly...
Can't do, yeah.
This is can't do on here.
Yep. I told you that earlier. I didn't do it on purpose. But it happened. So I can only be so angry at the book.
So if we on the test or something, if we ever see like an e to an x with something going on to the x, the power of the x was proved, we automatically can know that unless, you know, unless that variable is in front of the, it's
Yeah,
impossible.
unless it's got the derivative of that part out there somewhere.
It's just totally
You
impossible.
can't do
even
it.
touch it. Okay.
Exactly.
Well, it's at least a really easy way to identify it.
What's that?
It's a really easy way to identify it at least.
Yes, that's one thing to look for. Yes.
I think I did on the problem 57, section 5.5. I'm just getting a different answer from the book.
5, number...
57. Just can't figure out.
Sorry.
Let's see. So 57, integral 0 to pi, secant squared t over 4 dt.
Let u equal to t over 4. I don't know if there's need for it.
I like the way you said that, because it's just a simple little thing that you really don't need it. Because here's what I would do. I know the integral of secant squared is, so it's antiderivative. If I took this guy's derivative, if secant squared this times 1/4, so I know I need a 4. Because if you do the u equals t over 4. du equals 1/4 dt. So I need a 1/4 here. What do I put out front? 4. That's the 4 I just figured out on my own.
How did you do that one? When you said tangent t over 4?
So I know the integral of secant squared something is tangent something.
Okay.
Especially because the inside is linear in t. You got to be really careful. If it was t squared over 4, why do I know this is one I cannot do?
You can't divide by the constant, or not the variable.
More directly, what's the answer? Why can't I do, if this is t squared over 4, I'd have to have what out here? Something like t. The number doesn't matter because I can always make it show up, right? So if this is t squared, I'd have to have t out there, some kind of t. Right? Okay. So because this inside is linear, integral secant squared is tangent of what's in there. The derivative would have a 1/4 come popping out. Is there a 1/4 here? No, so I don't want the 1/4 to be there, so I put what will kill it. I really want you guys to understand that. And if you don't, it's not the end of the world. U substitution gets you through it. But since integration is the opposite of differentiation, you take a stab at what it is. I'm going to check it now. I'm basically checking it. The derivative would have a 1/4 there. Oh shit. I don't want the 1/4 there. Let me put its opposite there. If you don't get that, then the U sub will get you there because you put a 1/4. If you put a 1/4 in here, you got to put a 4 out there. That 4 is there. Now you got to go from 0 to pi. Is that part of the problem or no? Okay. Because now you just got to plug in pi.
I missed the 4. Because when I let u equal 2/4, the u was only 1 dt.
Neat.
So I
Yeah.
took the 4 out.
Gotcha. That won't work yet.
I thought those were gonna cancel, the 4 and 1/4.
I put them there. So, it's sort of like when I first teach my students LCD. So what do? They do 7x plus 2 times 2x over 2 times 7. And they go, oh, the 2's cancel, the 7's cancel. No, wait, what? So I put them there just so I could do the next step. I put these there just so I would be able to do the next step. I know they would reduce just like these would. And we know this is completely wrong, right? I'm not going to just reduce it back at, 7 times that. Oh, the 7's. 2 times that. Oh, the 2's cancel. No. Of course they do. That's why you could put them there. Okay, sorry. I'm getting out some frustration from another class.
Venting.
Okay, and that's cool from there, right? Okay.
Tan 0, 0.
Yeah, so tangent of pi over 4 is
1.
1. And then tangent of 0 is 0. So, we're good. 4. Crazy.
Time to go away.
Alright, so don't forget, there will be one problem that will involve the limit summation stuff. So I will have the
You're gonna give us
sum of I squared, sum of I cubed stuff. You with me?
You'll give us what I squared and cubed, right?
That's what that's what I meant. I'll give you what those are.
So is there anything else on this practice test that's going to be on the test that isn't there besides the sum?
Yeah, I mean that's why I wanted to say that because it's not here. That's the only thing.
Okay.
Yep.
That's the limit of goes the limit which is infinity to xi.
Because all I have to do is turn it in and just do the presentation.
Yep, like that.
Okay.
Thank you.